going to go over a couple conversion things, formulas for rectangular to polar and backwards. Rectangle coordinates to polar back and forth, right? So you got to remember, how do you plot polar points, right? Well, from the polar axes, you sweep around through so many degrees or radians out to some radial length. So the points here are r comma theta. If we drop down perpendicular, we can look at this in terms of x and y, because we can call this length y, this length x, and then through simple trigonometry we state our relationships. Obviously, Pythagoras would tell us x squared plus y squared is equal to r squared, and the tangent of theta was equal to y over x, so therefore theta would equal the inverse tan of y over x. That's the inverse tan. Okay, so there you go. If given x and y, you can find r theta through this sequence of conversion. For instance, given the point 3 comma 6, that's assumed to be in x and y coordinates, convert to polar. Well, simple. Okay, r is the square root of x squared plus x squared plus y squared, so it's 9 plus 36, otherwise known as root 45. So I guess we'll rationalize that, or just clean that up to 3 root 5. Okay, that's r. What's theta? Well, theta is the inverse tan of y over x, so that's the inverse tan of 6 over 3, which is the inverse tan of 2. It's not a familiar number. Look it up on your calculator. It looks like it's going to be 63 degrees. So there's your r theta equivalent, is 3 radical 5 comma 63 degrees. On a test without a calculator would give you a more familiar number. Okay. What else? Well, okay, coming back to our basic triangle up here, we identify that the sine of theta is the opposite of the hypotenuse, so that's y over r. That's y over r. Cross multiply, you get r sine of theta is equal to y. Okay, the cosine of theta is the adjacent over the hypotenuse. That's x over r. Cross multiply, r is equal to cosine of r cosine is equal to x. There's your conversion going from r theta to xy. Case in point, given the point, let's say 3 comma 5 pi over 6, find, that's obviously in the r theta format. Let's find the xy equivalent. All right, x is r cosine theta. That's 3 times the cosine of 5 pi over 6. 5 pi over 6, of course, is in the second quadrant where the cosine is negative. So it's 3 times some negative value. Reference angle is pi over 6. For cosine, that's root 3 over 2. So it looks like the x coordinate is negative 3 root 3 over 2. The y coordinate is equal to r sine of theta from here. So that's equal to 3 sine of 5 pi over 6. So again, sine is 5 pi over 6 is second quadrant. Sine is positive. It's 1/2, so 3/2. Our point is -3 root 3 over 2, comma, 3/2. That's the coordinate of the, that's the polar equivalent of 5 pi over 6. Now we can use this formulation also to convert polar equations or polar representations of graphs, okay? Something of this sort, r is equal to 2 plus 2 cosine of theta, 2 cosine of theta. We should obviously recognize that that's a cardioid, okay? So that's a cardioid, and we want to try to convert that into x and y. One of the suggestions is to multiply both sides by r. So if both sides are multiplied by r, I get r squared is equal to 2r plus 2r cosine of theta, distributing the r. Okay, we recognize from our basic, this is 2r, from our basic conversions, okay, r cosine of theta, as stated up there, is x. R squared is x squared plus y squared, okay? So this is x squared plus y squared equals 2. R must be radical x squared plus y squared. And then that's plus 2 r cosine of theta is x, so there we have it, okay? Doesn't look pretty, but then again, okay, it's probably better off in this format since this is not a function, but okay, problem is done. Take another problem. All right, let's take another problem. So here let's take one that's not going to look obvious in polar, but when we convert it over, it'll look obvious in rectangular. R is equal to 12 over 3 sine of theta minus 2 cosine of theta. Okay, cross multiply. Cross multiply, we get 3 times, and we're going to get r times the denominator here, which I'm just going to distribute in one line. 3r sine theta minus 2r cosine of theta, all right, is equal to 12. There's our y, there's our x. 3y minus 2x equals 12. Looks like the equation of a line, okay? Looks like the equation of a line. In fact, you can graph that quite easily, okay? When y is 0, x is -6, and when x is 0, looks like y is 4. So there's the equation of that. That's the equation in rectangular. How do you go back? How would you go back to putting that into the polar form? Well, just remember, okay? Y is r sine of theta. Just, okay, plug it back in. You go to that, get back to that. Cosine x is r cosine theta. Plug it back in. Go back to that. Pull out the r. Solve for r. There you have the equation of a line in polar versus the equation of the line in rectangular coordinates. Let's look at one more here. I know people had issues with something that looked like y is equal to I don't know, I think it was the double angle identity. We'll look at 2 cosine of 2 theta, right? Should realize that this is some kind of a shape like this, which we called a 4-leaf rose. I think it's something like that, okay? Well, of course, that's R, not Y. Okay, so and I think one of the things you want to incorporate is double angle identity. The cosine of 2 theta was equal to a couple things: cosine squared of theta minus sine squared of theta. And I guess we could make this drop down to 1 minus sine squared of theta minus sine squared of theta. So, so we could make this 2 times 1 minus 2 sine squared of theta. Okay, so we know that R is the square root of x squared plus y squared, because we know r squared is x squared plus y squared. And we also know, if we come back here, that r sine of theta is y, so sine of theta must be y over r. All right. So if we come back to our problem at hand, do a little distributing. Okay. This is going to come down. X squared plus y squared. Okay, we really should account for both positive and negative on that. I'm going to do the distributing. 2 minus 4 sine squared. Well, again, why did I just show you that? Sine of theta is y over r, so sine squared is y squared over r squared. Replace r squared with x squared plus y squared, and we're pretty much where we want to be. So I'm going to do that. Take a lazy way out. X squared plus y squared. And there it is. That's your conversion on that guy. All right, so you got some to practice. I'll give you some more in class. All right, that's good stuff to know. Okay, go over it. Make sure you're good with it. And now I want to stop. There we go.